the screen again. It's always good. Oops. It's a camera, don't worry about it. They're fine. Screen, proper text sizes. Okay, so I'm just going to start. My name is Erik Beaumont. You may know me from such demos as XSI 1.5. We forgot the poly tools. And XSI 3.0. We still don't have particles, but we now have awesome hair. So today, hold on a sec. I'm getting this weird thing in my ear. Jeez. There we go. I don't have pierced ears, or I didn't until a second ago. Okay. So I'm talking about Ventuz. The biggest problem about talking about Ventuz is nobody knows what it is. So I'm going to spend most of this talk actually telling you what Ventuz is. And originally the talk was something like why people should look at Ventuz, which is a really, really hard question to answer. So I'm just going to talk about Ventuz, and then at the end you decide whether you wanted to look at it or not. So we have to start off the talk with what is Ventuz. So rather than just talking, I will start off by showing you a quick showreel. And there's some sound here, but I'm just going to ignore the sound because connect. Make sure the device is turned on and discoverable. Okay. It seems to be on and discoverable. Whatever. So what you can see is Ventuz is a real-time rendering engine, an authoring tool, and a bunch more. And it's used for a whole wide variety of applications. Amongst other things, presentations, high-end presentations, Microsoft. We've been around for about 11 years doing this, and we're one of the best-kept secrets in the industry. So here, for example, Microsoft, that's 18 presentations, each 20 minutes. Any of you who've worked with Microsoft know they like to change their minds all the time. So if they're in the middle of a presentation and somebody goes, oh, by the way, we changed our product name, Metro is now whatever it is now, you need to be able to change it immediately, not re-render stuff. So real-time comes in pretty handy. Strange screen formats. It's not 16 by 9 square, but weird shapes, weird sizes. Real-time's really good for that. Pre-rendered, sometimes a little bit of a problem. A lot of interactivity. If you're doing any sort of interactive system, whether it's with encoders or touch screens or whatever, you have to be in a real-time environment. And especially in weird setups like this, where you have some weird controller that somebody set up, and then a weird touch mannequin, and a presentation running in the background, it has to be real-time. There's no other way. And you need a system that's very open and flexible, allowing you to bring that data in and drive your content with the projection mapping. You saw with the projection mapping, the cars turn. There's no way to do that in a non-real-time environment, right? Because you need to know exactly how far the car is turning in order to get everything matched. Here you can see it's a touch screen, but it's on a motorized chassis, so as you move the screen around, the content moves with it. Big, multi-user, multi-touch, everybody just comes and says, I want Minority Report. I know it's 15 years ago, that's still what everybody says. And it's like, I have a vision. It's like Minority Report. Oh, that's new. Here we have another sort of art display. This is actually for Nissan, I think it was, for the Juke. They basically put a touch screen with some paint stuff in the back, that's all Ventuz, and they projection mapped on Paris, and they have these graffiti artists that they hired. They smeared all over the buildings and drove off before the police came. Porsche has been using us for many years now to do their launch events. Most automotive manufacturers actually use us. The cool thing with the Porsche one is they actually had it interactive, so the designers could draw on the car and explain their design lines and why they were doing what they did. Yeah, so Audi has been using us for their big showrooms and stuff. Museum installations, aquariums, all of that sort of thing, where you need dynamic data, whether it's a touch or in this case just a sensor of somebody walking by and the fish sort of chase you around. It is a 3D engine, handles some pretty large 3D data. Here's a different one, fiducial markers. It's one of those things, you put a perfume bottle on, it has a unique ID at the bottom, and then it builds up the presentation depending on what, and it's all built into a grand piano. And that was a huge waste of a grand piano, but whatever. It actually is a really cool display because you just stick your perfume bottle, it builds it up graphically, stuff like that. So that's some of the things we do. We also are used in stadiums for the big LED walls going around. So a good example is Manchester City or Chelsea. The new football stadiums, they have these LED ribbons, and it used to be they just put sort of advertising up on it. Now, they have all sorts of interactivity, crowd stuff, social media. Yes, I know, social media. Everybody wants social media. But, you can put a Twitter feed up on your stadium for some reason. But basically, it's that sort of thing. It's very easy, it's real time, you can tie in data. So, the problem with Ventuz, we've been around for 11 years, is that it was always a little bit difficult to use. We're in Germany, so I can say it. It's German engineering at its finest. Phenomenally powerful, very flexible, and an artist looked at it and ran screaming. So Ventuz 5, which is the new version that we're launching, or we just launched a couple weeks ago, we're releasing it early next year, is all about the artist. The whole idea is let's take this tool and actually make it usable for an artist, which is a novel concept for us. So what I'm showing you here, a word of warning. I downloaded this build yesterday, and I haven't actually really tested it. So this may go down in flames, but I figured I have two choices. Either I can show you the really new stuff, or I can just show you something that works. I figured let's go for the risk and show you some new stuff. I apologize in advance if this all goes horribly, horribly, horribly wrong. So, the first thing we need obviously is Ventuz. Oh, you can see it's a good start. No icon, fantastic. Oh, that's good. Promising. So Ventuz 5, this is the design tool. This is basically the tool where we create the content in it. And yes, it's called breakable. And we're going to ignore all those scenes. So this is the new interface. And what you can see is it's like most tools in this genre, kind of dark gray. You can change to light gray if you prefer. We have here, it's a node-based tool. So we have here a hierarchy. This is your scene graph, very similar. Here's where you build logic, node-based environment, plug things together. Here's where you do properties. And this is a layer-based compositing system. We'll come back to that later. So let's think of Ventuz a little bit like a combination between an authoring tool and a compositing engine and a really, really stable, solid game engine. But what we don't do in here is we don't create assets. That's not what we do. Okay, there's other tools, there's many people that make amazing content creation tools to create 3D tools and whatever, and we'll use those. So it's not a modeling tool, it's not a texturing tool, you can animate in it, but that's it. So what I need to do is I need some assets. So in this case, one of the things we've done is we've actually cooperated with Max on Cinema 4D. Remind me later, do I want to participate? Yeah, I'll participate later. Okay, so what we found is a lot of artists were using a lot of 3D assets in Ventuz. I mean, it is a 3D engine, so you want to use 3D assets. But the whole import-export thing doesn't fit the real-time pipeline very well. Especially not if you're going in, you're doing projection mapping maybe. You have your 3D model that you're going to be projecting onto. And a lot of the projection mapping workflow is you sitting there moving UVs and points so that it matches from your projectors onto the model. The last thing you want is have to import, check it, wait, yep, no. Tweak, check, wait. It's not a solid workflow. So what we did is we decided to build a live link so that other softwares can talk to Ventuz directly live with passing the updates through. And in this case, we started with C4D, but if there were, say, other softwares that can generate really lots of geometry in real time, really cool, hey. So that's a good start. It's now thinking. Why is this not doing? So we have something in here, which are just Ventuz tags. And there's two tags you'll notice, and they're really, really small. The first tag basically is the top of your scene, and that just says, all of the stuff that follows on, bring that in. So if you have a big hierarchy, a virtual studio, a virtual set, something like that, you want to bring it in, you can do that. And the second one actually says what properties of the object I'm actually going to bring it across. So we have here. By the way, this is a completely non-canned demo. I'm making this up as I go along, so I'm not a designer. I apologize in advance. I'm going to bring in a geometry import live. So what this does is this says, hey, there's something coming from somewhere else. Go pay attention to that over there. And you can see all these sorts of things. I can check what I want to bring in. One of the things is make sure the scaling works there. There is Max and Maya here. That doesn't mean we have a link. It's just because somebody decided to put that in. I won't comment on that. There we go. The next thing, of course, I have to make some sort of update because I just dragged this in. So I'm just going to say there's force a refresh there. You can see it's updated there. And, oh, that's good. Good start. Oh, of course, I didn't actually link it. I do actually have to tell it to connect to it and then update it. Okay, so now what it's done is it's brought across the scene graph from C4D. It's brought it across live. And it's established a live link between these softwares. And a really, really tiny here is this sphere. So anything I now do in C4D is brought across into Ventuz. So if I start exploding it, anything like that, there it is, and there's a live link between the meshes. So we're basically streaming the mesh in live from one software into the other. And the cool part about this works over a network. So you have some guy doing your 3D modeling, your texturing, all of your UV space, and the other guy is setting up all of the logic and whatnot in Ventuz to create it, and they're working simultaneously passing across. Or you're setting up a projection mapping environment with all your projectors, and then some guy's sitting there just modeling and tweaking the UVs onto the projectors. So once it's in Ventuz, we can do some more stuff with that later. Oh, actually, one thing I should probably do is bake across some animation just so I have it. So I'll just animate something. Boom. Okay. Actually, you know what? I'm going to turn off gravity. I wish I could do that. There we go. Okay. So turn off gravity, and let's just make it blow up a bit more. There we go. Add a keyframe. So one of the important things about Ventuz is that we're a nonlinear engine. You have to be nonlinear if you're in a real-time environment. You can't have a linear timeline at the bottom and then have somebody, moving a menu, because that doesn't sort of work. So getting a linear timeline across from Ventuz is a little bit weird. All I have to do is basically say what chunk of animation, and I just create animation. So now Ventuz has that chunk of animation, which then I can use in whatever time frame I want to use, right? So you can animate, you can see it loops indefinitely if I keep scrubbing. I don't know why we did that, but okay. So once it's in Ventuz, I have a whole bunch of things I can do with it. First of all, I can obviously animate it. Now, let's go in here, and I'm just going to open up my toolbox because you guys should see all the fantastic tools that we have. So you can see that it's a node-based environment, and there's all sorts of tools in here, the kinds of things you'd expect. However, if you're used to a node-based environment, the one thing we don't do, almost all of the node-based environments, for example, ICE, for example, Fabric Engine, those sorts of things, we don't modify meshes. That's not what we're about. We're about tying real-time data to your content, moving it around, connecting it to real-time inputs like controllers or anything like that, animating it in that kind of environment. We're not about modifying meshes and creating procedural meshes, anything like that. That's really not what it's about. So we have things like database queries. So if you want to, create a touchscreen application, and there's going to be, all sorts of assets in a database behind, we don't want you having to write an API to connect to a database to get your text and your assets and your images and your movie clips in there. It should be really, really easy. So for example, a database, all I have to do is bring it in, say, okay, it's going to be an Oracle database, and I get a SQL query, and now I type in my SQL query, select star from Bob, and save and close it. And now I have that linked, and I can fire that off with an event. I can trigger it based on a touch or based on some sort of timing, but it's really easy to set up these data links and that kind of thing. There we go, so I can just link that together. And you can see then it's a node-based environment just like everybody else has, but it's really not about modifying that geometry. So instead, what I'm actually going to do is I'm going to make this touchable. So we have the interaction nodes. Touch screens is one big thing we do. So I'm just going to put a touch orbit node on there, and I do need to actually just go in the touch orbit node and say to actually use the mesh. Okay, so now it's multi-touch. I don't have to program anything. I don't have to go in and do anything, in terms of capturing the touch points or anything. If I had a touch screen, which I actually do, but it broke because somebody put their suitcase on top of my laptop, I could actually touch it and show you it on my laptop, which you wouldn't be able to see anyway because my laptop's here and you're over there. So we can just ignore that. Anyway, but I can use my mouse, and you can all believe me that this is multi-touch. So what I want to do is I want to connect that animation that I've done in Cinema to something here, so I'm just going to get a linear interpolator. We have all the maths effects and those sorts of fun things. And you can see that the touch has all of the outputs, and if I turn on live mode, so view the things, you can see on the outputs, for example, it's firing all these touch events. Let's just make this a little bigger. So you have things like booleans up here, and you have events down here, and the minute my mouse goes over it, it's firing off these events. The minute I rotate it, these values are going to 8 decimal places, all sorts of fantastic things. But what I'm going to do now is I'm going to actually use this linear interpolator to animate between these frames. So I just drag the property onto the interpolator, and I'm going to say it's going to be from frame 2 to frame, I can't remember how 27. Okay, so there we have a now linear interpolation, and I can toggle that on and off. That's great. And I'll make it a little bit faster, 0.5. That's better. So now I have this Boolean value, and I want to drive that with touch, so all I have to do is grab the Boolean value and drop it onto the touch, and I'm going to say touch press. So the minute my mouse goes over it and presses, I have the animation. and then the minute I let go, it's gone again. Okay, so it's just this kind of logic, building it up. Things like text elements. So if I have a text element, there's a lot of 3D engines out there, a lot of real-time engines. There's a lot of game engines, Unreal, Unity, all those sorts of things. The things that you need in a professional environment when you're doing things are often not the things that they're really geared for. Things like text is one of those. Everybody says, well, text is really, really, really boring. Yes, it is, but having good quality text is actually probably going to be 80% of your work if you're in that kind of environment, if it's a museum or something like that. So there's a couple things about text that people don't realize. Number one is, real-time text is really, really hard. People don't realize quite how hard it is, because if you have a paragraph of text, you have 16.7 milliseconds, which is one frame at 60 frames per second, to render the next paragraph of text. And you have to be able to do the entire paragraph from one frame to the next. That's a lot of rendering, because text is really sort of precise and there's a lot of detail. Now, if you have Chinese, that's 65,000 characters you start with. So at some point, you can think, okay, well, we'll just use the most used set, but then your customer is going to be quoting Confucius or something like that in some random setup that you've never predicted, and it's not going to work. So we have to actually pre-render 65,000 characters. If you're using Chinese, you can turn it off, of course, and be able to change it from one frame to the next based on an RSS feed or a JSON feed or a social media, and then the social media person almost guaranteed has some weird smiley that you never thought of. So we have those sorts of things, and we have to have the ability to have that. The other thing that's really important is that if you're doing a big screen, text has to be resolution independent. There's absolutely no reason that you should have a text, you zoom in all the way, and then you have all the fuzzy edges and aliasing artifacts. And you think, okay, well, that's easy. It is in like a Word or something like that, but that's not built for real time. You just don't realize it, because if it takes half a second to render something, you don't care in Word. You would in a real-time application. So what we have is actually a text engine that's resolution independent. And you can zoom into these curves as far as you want. Wow, that's really weird. There's a lag between here and here. I see things moving like seconds after I do it. Cool. I just move it and then my text ghosts over. It's like, wow. Okay, but you can see it's like this really nice crisp edge, and that's all. But this is actually being dynamically generated, and it is a true 3D text. So if I manage to find my text again, where is it? There we are. Go away. Thank you. So what I can do is, of course, all I can do in my rotation, it is 3D. This is actually, in fact, also a shader-based system. So this text itself has things like styles. So I can go in here and say, let's create a text effect node. Let's give it a glow something. I don't know. Let's make an offset and make it all sort of, whoops, blurry. And then let's make it sort of a little bit transparent, and, whatever. Make it like a blue, something like that. Anyway, you see these are real-time effects. Now, the cool part is that the input of this text is, of course, a live parameter. So if I had an RSS feed, if I were connected to the internet, which I'm sure I'm not, but if I were, I could then just plug in an RSS feed or a JSON, so you can get social media directly in. XML, you can just read in an XML file, whatever. You don't have to write an API. For those people that are in the masochistic department, we do actually have scripting, so you can write in C#, .NET, whatever you want, build your own nodes that do data processing, all of that. But again, we're not about deforming meshes or anything like that. We're about processing data, handling all that, passing it. A good example is Who Wants to Be a Millionaire? So most game shows around are actually done with Ventuz. You'll never hear of it because they just put a black box that says Who Wants to Be a Millionaire in there. But they have 65,000 nodes in their scene, which is doing all of the SMS processing. All of the voting, all of the building and construction of scenes, all the passing out to video walls, all of that stuff. And they just build it with logic in the scene, so they don't have these external control apps that they're programming, trying to make sure so you have one contained environment. All right. Anyway, where was I? Oh yeah, right. So text, we can do all that sort of stuff. And you can see the logic nodes. I have 45 minutes to talk. If I show you everything, we're going to be for 7 hours. But we have, all of the logic nodes to do basically visual programming in that data format, string processing, stuff like that, matrix operations if you're in a virtual environment for virtual studios, matching cameras and all that nonsense. And things just simple like operations like toggles and events and all of that sort of stuff. I/O inputs, you want a mouse input, you want a joystick input, you want anything like that, we have it here. OSC, so you can tie it to other control systems that you build yourself. Somebody builds an Arduino controller that's doing a temperature measurement and a date combiner, and then you can have one display on Friday the 13th and a different one every other day. Something like that. It's very, very easy to tie those things in together.
proximity sensors. MIDI control for all the VJs out there that want to have a MIDI controller and drive their presentation with a keyboard. You know, interaction stuff, touch markers. So if you have fiducials on a touch screen or something like that, we can do all that. Now, this is all fine and dandy, but the interesting part really comes to some of the new improvements in V5, one of which is the material system, because up to now, we basically had a DirectX pipeline, which means you had to visually program DirectX in our software, which is not real artist friendly, I'll tell you. So what we now have is an actual material system it's real time, but it can do a whole bunch of cool stuff. And this is an entirely new engine, which is very, very funky. So one of the things we've implemented is image-based lighting. And this is completely new, and I haven't actually really played that much with it because it was done on Monday. So our engine is actually HDR capable, even though it's real time, which gives us some interesting abilities. So first of all, I can turn it on to HDR, and we do have 3 modes. I have no idea what the difference is. You probably know better than I do, but I'm going to leave it on Reinhardt because that sounds like he knows what he's talking about. And what I'm going to do is I have here, first of all, the image itself. It's an HDR image, and so what I'm doing is I'm setting up this image-based lighting system. So what I want to do is I want to add a pre-blur to the texture that I'm going to use. So what we're actually doing is tone mapping. It's a technique that's used in most of the game engines. So it's a pseudo PBR. It's somewhere in between the worlds of real PBR and not PBR, I guess. And so what I've done is I've just added a blur, and it's mapping this image a little bit like an environment map and using that for the lighting as the lighting channel. So when I actually go in here and touch it, you can see even though it's spread about, you're getting actual, the real lighting effect. And it works real well on your 3D objects, forget it. And it is HDR, so I can go in there and blow up my exposure. One thing I should do is turn on some bloom. Bloom, there we go. There we go. So that's all very spangly and shiny and looks a lot like nothing. All right. So I'm not a designer, like I say. So we can turn that back again. Every parameter in here can be animated. Again, connected to data, whether it's animated in here, real-time data coming from an external source or whatever. Now, the way that we've set this up, actually, you know what? I'm going to kick that for a sec, and I'm just going to do something else. The way that we set up this texturing system is you have your channels. This is a standard gaming texture pipeline, basically. So you put your textures onto the channels. So I have a diffuse texture here. Let's get a different diffuse texture. I don't know, that. And it just puts it on. And now I have a couple options. First of all, I can change my sampler if I want it to be, for example, in a wrap mode or something like that. Whoops, there we are. So I can set this up. But you'll see it's on simple. If I want advanced, then I can go into there, and then there's all sorts of properties that I don't know what they mean. So we'll just go back. There we go. Simple wrap. Okay. And then the next thing we have is the mapping. So what UVs, etc. are we using? Now, by default, we just use some simples. Again, you can't change it. But the typical reflection, UV maps, and we support 2 UV sets. So if you're baking your ambient occlusion in one UV set, and then you're mapping your diffuse on the other, you can do that kind of stuff. So what I'm just going to do is I'll just leave it on UV, that's fine. Each channel, we say, okay, the color in the alpha, we separate, you have a target. Where is the color going? You have an operation. What Photoshop blending method are we using? And a mask, so if you want to use a mask, write to a mask earlier in the texture stack, reuse it. So why would I use that? Well, if I put another texture on, let's put another diffuse texture and say we're just going to use some sort of crazy sphere map. Here we go. And wow, that's weird. Go into here, simple wrap, and I'm going to go to simple spherical. There we go. So now I have this sphere map right on top of my diffuse channel. And of course I can change the order, but the one thing I probably want to do is I might want to put it in a multiply and just bring it down a little bit with the opacity slider. And again, this is all animatable, and you can do that. So that's pretty cool. And then I can add things like normal maps, displacement maps, rim lighting, which is essentially from Softimage, it's the incidence shader. So angle-based, normal to camera, normal to light, whatever you want to do, map a texture across it, those kinds of things, but in real time. Cell shading, which does cell shading, and some vertex noise sort of things for making things look ugly. So we can do that, and then we can animate it and make it do sparkly, things like that. So there's a lot of possibilities just in the material system, but the cool part is this is one node. So there's one node sitting in front of the material, which means I can create presets, reuse it, all of that sort of thing. Now, the thing that's missing is this is great and grand and it's beautiful and all that. or not, but it's there. But what I'm missing is the ability to build up scenes, and that's where we've actually built this entire layer system. And one of the problems that we had is people would sit down at Ventuz and see these nodes and get these giant scenes that were very hard to debug, and everybody says, well, can we just import After Effects? And we go, no. So instead what we actually did is we tried to sort of recreate the workflow for a compositing system. And internally it's a node-based system, but we started with just a layer-based approach. So what I have is I have a compositing system here where I can load 2D layers and 3D layers and just combine them, but it's real time. It's basically a compositing engine that's built around the concept of let's do everything in real time, and everything should be animatable, and everything should be controllable with data and all of that sort of thing. And we tried to do as much of the stuff that we can that you would do in an After Effects or something in this real-time environment. All of these effects are geared toward being 4K, and one of the things Ventuz does really, really, really well is if 4K isn't enough, you start clustering machines together in a real-time render cluster kind of thing. So we have presentations right now running at 60K, you know, masses of screens, huge LED ribbons, those sorts of things. And our machines can be added together in a clustered environment, absolutely frame locked. Not just frame locked to the frame, but also fill rates and all of that sort of thing. And that's what we're very, very good at. So, and I'll show you those tools in a little bit of a sec. But these compositing effects are built for that kind of an environment. So let's see what we can do. Let me get a movie layer of some sort so we have something moving around. Oh, you know what I could do? I could really try and break it. Let's try and break this and see if my live video will work, because then you can look at my face the whole time. Yes! Okay, so I'm now going to do some compositing with real-time data. Hi. Okay. No, that's actually hideous. Never mind. Stop. Let's go back. Well, it doesn't matter. It's too late now. We've gone this far. We're going to go further. So I can go in. All of my Photoshop blending methods will work. We do a lot of TV work. I don't normally show that in the showreel stuff because it's kind of boring. But if you've watched any sorts of weird sports like snowboarding, windsurfing, caber tossing, anything like that, that generally actually is Ventuz, because there's 1,000,001 graphics packages for soccer, but there's none for advanced wakeboarding. And Ventuz is really handy for building your own solution for that. So just to give you an idea, Fox Sports right now has 200 channels running on Ventuz, and nobody knows it, so now you do. You're amongst an elite few in the world that actually know that. So we can do a whole bunch of things. Obviously, it is a compositing system, so we have the typical sorts of ability to position it. We can move me off screen, move me back on screen. Hello, back and forth. We can do things like resizing, pictures in pictures, and all of that sort of thing. We can also do your typical sort of effects like polar coordinates for all of the Andrew Kramer friends. There we go, for your video copilot, circular kinds of effects. And then for some reason our developers put in a kaleidoscope effect. It's cool. I'm sure somebody will use it someday. The interesting part is, okay, so this is all 2D content. Exactly the same stuff is available for the 3D content. So it really is a 3D, 2D compositing engine. And because of the live link with the meshes and all that, there's no differences between 2D and 3D. It all just sort of blends together and merges into this one giant mess. Let me just go back here into a sort of a normal mode. Now there's one other really, really cool thing, is that every layer also has effects. So far, right now, we've only exposed the 2D effects, but by the time we release it, all the 3D effects will be released as well. So what kind of effects? Well, things like maybe a blur. So it takes a sec. And this is, of course, on my laptop, so now I have a blur effect that I can animate, that I can change, a little bit less, a little bit more. Okay, and I can go in and maybe do like a color correction, something like that. We have color corrections and grading and all of that sort of thing. But again, this is this sort of real-time environment, and I'm not having to render out any of this stuff, and it's immediate. With an image-based lighting 3D engine inside, and all the 3D content and 2D content is sort of merged together in one giant bundle of joy. Things like 2D displacement, so I can actually bring in a displacement map. And this is for things like virtual sets and stuff like that, where you want to displace your content, or it could be some cool VJ effect, I don't know. So stuff like that. So now I'm using this 2D effect. But we have the whole ability to write any of these layers into a texture and reuse it for other things, like map it on an object or use it as a mask. So what I could do, for example, and this is going to be really weird, is let's just take another 3D layer and just dump that on the top. Oh no, that's the one I already used. I really should name things. It's one of those, standard things that everybody learns, and 15 years later, I still don't name anything. Okay, and what I'm going to do is I'm going to take a sphere, maybe, and let's take an axis. I don't know. And basically, instead of actually writing this out onto the screen, I'm just going to write this out into a render target. It's basically, I'm writing this into texture. And I'm going to use this as the you know what I'm actually going to do? Instead of doing this, I'm going to use it as a mask, because that way you'll actually see the difference. There we go. So now we have this mask, so it's background image in one and foreground image in the other. And what I'm going to do is I'm going to switch this and tie these two together in a very clever maneuver, just by dragging and dropping. There we go. Okay, so now we have a sphere, which is a real 3D object, which is now my mask between the two elements. So it's like a pre-comp almost. But of course this can be animated, this can be triggered by touch, this can be whatever you want. And all of the effects that I have also apply to the mask. So I can go and say, I'm going to put a mosaic mode on here. Let's do a 3x3 maybe. There it is, that's sort of cool. And then let's put a feedback, so I have a little bit of a delay in it. And now when I actually move the sphere, you can see I get this sort of pixely kind of effect, those sorts of things. But I'm just building this in real time, and I'm not having to render any of this out. And if I want to change it, I can change it on the fly. So when the customer says, yeah, this is great, can you do it in green? You go, yeah, sure. Add a color correction node, correct it to green, and that's it. Okay. So now let's make this whole nonsense for a video wall. This is going to go horribly wrong, I'm sure. So because I'm doing this on a laptop, and it's going to be like... So the first thing is I have to remember where the heck the... There we go. So here's my stage editor. So you can see right now it's outputting to 1 times HD. This is easy. Oh, this is new. Interesting. Ventuz configuration. Buttons, things, none. Create new. Sounds good. Let's try this. Like I said, this is all new. Okay. Layout configuration. Yes, I will create a layout configuration. I'm going to call this Erik's whatever. There we are. Active. Yes, I think I want to update this. You tried? Oh dear. Oh my. Okay, well, it should be okay anyway. So I now have 1 HD, and this is fine. Now what I probably want to be doing is let's put this on a video wall. This is a laptop, so I will be a little bit gentle on it. Let's put 4 screens per machine, and I want 4 machines. Okay, so I'm going to build up a 16-screen video wall. So this is my video wall. I'm going to position my machines around. There we go. Hit save. Failed to reload render stuff. That's fine. We'll just do it manually. Come on. Erik. There we go. So this is my 16-screen video wall. Now, you can see down here, my laptop is struggling a little bit to render 16K. It's kind of, chunky. We're actually rendering probably 4K blocks here, but it's struggling a little bit. There's an optimization that we normally do that sort of keeps it manageable even at small resolutions, but we haven't put that in yet here. So it's struggling, let's just be nice to it for a second, just make this a little bit smaller. Oh boy. Let's make this 2 by 1, and let's make this 2 machines, because then you can just see. It's okay, you'll be fine, you're fine. But like, it's beginning to take off, the fan's turned on and this thing going. So, there we go, and what you see, the first thing is when I put it to a rear resolution, it automatically stretches the content. The reason being, if you're in the middle of a live show and somebody moves projectors, you don't want black bars. You want it to quickly just fit. So that's the default behavior. If you don't want that, you can always go in here and just update the content to match. All right, so now it's match pixel for pixel, and I do have this layer here in stretch mode. So if I put it to crop mode, then it does whatever, but I can change that however I want. Now, the cool part about this is, let's say I have projectors. I can create projector blending, and all of the tools that I need for projector blending are in here. So shaping, warping, edge blends, all of that kind of thing. It's automatically in the tool. You don't need a separate tool set or anything in the projectors to do this. And this is built for huge numbers of tools. And I just realized my time is getting a little bit short. So the other thing that we can do, gaps, you know, you have a projector set up or a screen set up and there's gaps in it, bezel compensation, any of that kind of thing. Or you have internally daisy chain screens. So that happens a lot, is that there's screens that talk to each other and they have one output. What I can just do is I can subdivide these screens, and now we know it's one physical output, but we can set it up. Yeah, I know you can't find it, but it's right there. There we are. And you can see immediately that there's a gap, and as an artist, I can be building for this screen setup. Yeah, and it's immediately visible, but I'm using compositing tools and all of that. How much time do I have? Olli, wie viel Zeit habe ich noch? 6 Minuten. Okay. Animation in 6 minutes. Dun, dun, dun. And I was already talking really, really fast. You'll see how fast I can talk. All right, so what I'm going to do is I'm just going to go to none. Blah, 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 blah. You know, that's terrible. Test. What does test look like? Oh, that's even worse. Huh. Okay. Let's just make a new setup. Go away. Exit. And I'm just going to make a new setup with just HD because that's more sensible. And we're just going to switch to HD. Bam, there we go. Okay, so the animation system in Ventuz is actually really, really cool because it's geared towards nonlinear. So everything is what we call a state animation system. All right. So, oh, that's kind of weird because I forgot to do that. There we go. So now what I'm going to do is hide this, ignore that. There we go. Make it bigger. It's really hard to show the whole animation system in 4 minutes. Okay. So the way that we work is we have a keyframe animation node. And you animate inside here exactly the same way as you would animate in any other software with keyframes, which is why it's called the keyframe animation node. So what I could do is I can just go in here, add keyframes, do handles, but what we also have is a state-based animation system, whereby I can put states in here and say, okay, so here I'm going to be, I actually have to tell it also to have the right animation channel, because I'm in the wrong animation node there, yeah, that's why. So we'll try that again with the right animation node, makes some more sense. And I can just go in here, and what I'm going to say is right here we're going to be off screen, bye. And here we're going to be on screen, and then here we're going to be off screen again, something like that. Okay, so each of these connectors, really, really small connectors, there we go, is actually an animation node with busy handles where I can go in, do keyframe animation, do my handles, animate whatever parameters. And we have as many of these nodes in Ventuz at the same time as you want. So you can have different things happening in different time frames, so logo rotating here with something coming in the bottom and a touchscreen menu opening up there, all independent of each other. Because that's one thing normal compositing systems don't need, but in a real-time environment you do need that. So where it gets interesting, however, is the ability to drive all this nonsense with an external animation or external control system. So that's properties, will go away, we don't need that. And what I'm going to do is, oh, I do need the properties. Dang, I thought it was so clever putting that away, and then here I go, and there it is. Okay, now I don't need it, bye. Okay, so what I have here now is I've told Ventuz, hey, this whole thing, this should be a controllable from an external program kind of animation system. And what you can see now is I can just call up this position state 2, and there's all these little arrows. So Ventuz has a pathfinding system. So you can say, go there, and it finds its own way in the scene to get to that point. You just have to give it a target. So when I say, go here, young man, he goes out and then comes back in. So if I deactivate it, it goes out. If I say, come here, it comes back in. So if I add another state, and I say, well, okay, maybe I want a different position. Let's just make this a yellow guy 2, which means it's a present state. I'm going to put it at the top of the screen. So now I have 2 different ones. I have S2, go out, come back in. The only way to get to S2 is to go out, come back in. So now it's up at S2. If I want to say S4, the only way to get from here to here is to go out to S3 and come back in to S1. So there we go, goes out, comes in. Well, that's completely stupid. Nobody would want to do that. So we can start creating new connections. For example, I can do both directions. So now there's a transition between the two that I can go in, keyframe, yada, yada, blah, blah. Now, the other thing, of course, is that I need to also be able to create weird custom entry and exit points, because it's really stupid if I have an exit point or an entry point for the top at the bottom. It's going out the screen all the time. I want it to go out the top. So all I have to do is go in here and say beginning and end, delete these guys. Yep, that's okay. Goodbye. It's really hard to hit that with the mouse. There we go. And we just say, okay, the top is going to be out the top. Bye. And the bottom's going to be out the bottom, out the top too. There we go. Okay. So now what it does is if it wants to go to S4, it's going to come in here because that's the shortest path. If it wants to go to S2, it's going to come in there because it's the shortest path. So I can create all these animations that are all dependent on where it is and what the situation is, and it finds its way through these really complex animation systems. But the beauty of that is if I add, for example, like a text node, just randomly, it's not going to actually do anything, but just to show you the principle. Let's grab the property editor real quick. Where are we? I did need it again. See, I shouldn't have deleted it. There we go. And what I'm going to do is go to the inputs and drop the text node. I can link a data element with a channel or with this animation state. So if I get my text and I drop this in, I can say not only go here, but go here with this data. And the cool part about this is that this is a tiny little JSON file. So I just have this nice little command. This is a hierarchical position of that animation state within that animation node, within that scene, within that, with this metadata. So if I have a scheduling system or an automation system or my own control application, all I have to do is pass a tiny text file out and say, go there with this color, this image, this data, this movie clip, whatever, and it does it. So it's super easy to integrate inside of any other system. All right, on that note, you probably haven't understood half of what I've said because I've been talking about 900 words per minute, but you sort of vaguely got an idea of what I'm doing. If you have questions or anything, I'll be around at the party tonight. You can accost me and I'll be drunk, so you'll understand even less. Yeah, and I'm around anyway. You guys know where I live. Thank you very much.
Thank you.
Okay, thanks, Erik. Yeah, we'll have a short break. 10 minutes.